Peace. Welcome back. The topic for this video is how to factor binomials. Um, what is a binomial? A binomial is just a math expression with two terms. So, for example, a binomial would be something like 2ab plus 4c. This is a binomial. Bi, of course, means two. Nomial means number. Two numbers. So, really quick, just for some context, where are the two numbers in this here binomial that we're talking about? Well, we will talk about that in another video, but what you need to know is that the two numbers are separated when you're talking about binomials. Each number, because again, binomial means two numbers, each number is separated with a positive and a negative sign. So for example, this is the first number and this is the second number. Remember, this is a positive 2. So this term is the first number that we're dealing with, and this is the second number that we're dealing with. This is going to be true excuse me, for all binomials that you're going to deal with. All right, so now that we kind of got that out of the way, let's get into some examples right fast. All right, so again, what the topic of the video is, what we're going to be doing is factoring binomials. So when we're factoring, a good example to think about factoring is maybe the greatest common factor. So if we have the number 16, we can factor this out in a bunch of different ways. We could do 4 times 4. We could do 8 times 2. We could do 1 and 16. And all of these are factors that give you 16, right? So this same thing is true with algebraic expressions like binomials. So this whole thing right here would be like the number 16. And what we're trying to figure out is what can we multiply to get this expression right here. And so that's what factoring is all about. So the first step is we're going to, in this particular case, we're going to divide both of these terms by 2. We're going to look at what they have in common. So we could take a 2 out of this first term. We can also divide the second term by 2 because that's a 4 right there. When we do that, we get a 2. And we get, after we cross this out, we get AB plus, this is going to turn into 2C, and this is our factor for the binomial as earlier. If that doesn't make sense, just stick around. We're going to go through some more examples right now. Example number 2. I'm writing in a different color. We got t cubed minus t times s. So again, like I said before, we got a positive 1t. That's what's separating. So this is the first term and this is the second term. I'll leave that one right there. What do these two terms have in common that we can take out? Well, they each have a 1t. So we're going to divide both of these terms, both of these numbers by t, and see what we get. So of course there's some things that are implied. So again, t to the first is the same as t. So we're going to divide that out of both of these because we got t to the first in both of these terms. And that's going to give us t to the second minus s. And we're going to have t left on the outside. And this is going to be what we multiply in order to get our expression up here. The original expression was t to the third minus t times s. So moving on to another example. Let's see if I can get a different color. Go red. So now we have 3 times n minus 6 times m. Same process as last time. So what we're trying to find out is what do these two numbers, these two terms have in common that we can take out. Seems pretty obvious. We can take out this the 3 in both of these terms. And when you take it out, you want to put that outside of a parentheses, if I didn't mention that. So now that's going to leave us with n minus 2m. And this is the expression. This is what we multiply. That is going to give us 3n minus 6m. All right. Another example. And let's do 5 times y squared plus y. And again, just to reiterate what I did earlier, remember we're just looking for two terms that equal the value of interest or the expression of interest. You understand? So just make sure that you have that conceptualization in mind. So what we got to do now is find what two terms equal 5y squared plus y. And again, we're just going to find the common factor among both of these, which is going to be y. It's going to be 5y. Let's see, times y plus 1. Let me make sure I did that correctly. 5y divided by, no, see, I made a mistake. So this is going to just be y. I got y and 5y mixed up. 5y is going to be inside the parentheses and y is going to be on the outside of the parentheses. Because when you divide this by y, what you get is 5y. Because again, this is 1y to the first divided by 5y to the second. So 5 divided by 1 is just going to give you 5. Y squared divided by y to the first is going to give you just y. So this expression here is going to be the factor for 5y squared plus y. QR is supposed to be, let me put that in lowercase. q r squared minus r to the third. Same situation. What do these two terms have in common? They have an r squared inside both of them. So after we divide that r squared, what we're going to be left with is r squared on the outside of the bracket. Q minus r to r cubed divided by r squared is just going to be r. And this right here is going to be our factorization of the expression qr squared minus r cubed. Just a couple more examples. Let's do 3p squared minus 15q. Again, we're just talking about binomials. So I'll just stay on that track. So again, it's the same situation as the previous examples. What can we divide out of both of these two terms? I can see that we can take a 3. We can divide both of these, both of these terms by 3. So we're going to put 3 on the outside of the parentheses, or the brackets. And that's going to leave us, after we do that, it's going to leave us with p squared minus 15 divided by 3 is going to be 5q.